ये पड़ी हुई है कॉपी मेरी। यप। यहाँ पे मत आएगा। 5 मिनट तक स्टार्ट होगा वैसे तो। 2 बजे का टाइम है। लेट्स सी 2, 2, 5, 10 तो होता है।
Good afternoon, Ms. Tronda. How are you? Ms. Tronda, can you hear me?
Yes.
Thank you very much.
Good afternoon, everyone.
Most welcome. I think we have already tested our coordination work, but I would still like to give you the trouble first that please check if the screen sharing is okay. So can you check your screen sharing now, please? Thank you.
Yes. Just a second. Yes. Do you see it?
Excellent.
Yeah.
Yes, excellent. Thank you very much. So kindly unshare now so that we are now approaching 2 p.m. so I can start formally. So please unshare the screen now.
Just a second.
Yeah,
Yes.
Thank you very much. Thank you very much. So we still have 3 minutes, and Rizwan Mirza, today he will be my co-host. If anything goes wrong at my end, he will immediately take over my responsibilities. Khalid Bashir is there, a very senior engineer, civil engineer. Welcome, Khalid Bashir. Latif Bhatti, Tatiana, Mr. Latif Bhatti and Rizwan Mirza are among the founder members of this society. And they are very experienced civil engineers. My classmates also. Just for the introduction.
Tatiana, this is Khalid Bashir from Lahore. Hi.
Good afternoon, Mr. Khalid Bashir. Yes, right. Thank you for the invitation to become a member of the Pakistan Society of Civil Engineers. I'm going to fulfill all documents and I will send you Mr. Tahir Sultan.
Tatiana, before I start formally, I will just make one announcement in my language. Just for, it is an informal announcement. There are certain rules which we have to follow. So let me remind our participants about the about these rules informally. Then in English also, when I will start formally, I have to again read those rules loud. Okay.
Yes, okay. I understand.
ख़वातीन और हज़रात, मैं फिर आपसे गुजारिश कर रहा हूँ, आज एक इंटरनेशनल पर्सनैलिटी गेस्ट स्पीकर है हमारी, तो आप मुझे मजबूर ना कीजिएगा कि मैं बीच बीच में फिर अनाउंसमेंट्स करूँ। एक अच्छा तासुर नहीं जाएगा पाकिस्तान का। तो आप अपने कैमरा आपने ऑन रखने हैं, ये एक रिक्वायरमेंट है पाकिस्तान इंजीनियरिंग काउंसिल की, और इस पे हम किसी किस्म की कोई कंसेशन नहीं दे सकते। और इसलिए प्लीज आज आप अपने कैमरास अभी आप ऑन कर लें, जिन्होंने सीपीडी के लिए रजिस्ट्रेशन कराई है, तो मुझे दोबारा अनाउंसमेंट ना करनी पड़ेगी। थैंक यू वेरी मच। Bismillahir-Rahmanir-Rahim. In the name of Allah, the most gracious and the most merciful. Assalamu alaikum and good afternoon, ladies and gentlemen. A very warm welcome to you in lecture number 45, which is being organized under the auspices of Pakistan Society of Civil Engineers. Sorry, Pakistan Society of Civil Engineers. For the new participants, I just want to tell them that this lecture is in continuation of series of lectures that PSCE is presenting since 2020 for the benefit of young and experienced engineers. Our sole endeavor is to keep our fraternity abreast with the advancing knowledge in different disciplines of civil engineering. And I hope every young engineer will take advantage of these lectures. This lecture is also being transmitted live on Facebook, and where we have our participants from 3 continents, Europe, America, and Asia. Today's topic is ground improvement in Belarus. And our guest speaker is Tatiana Tronda. Before I introduce the speaker to you, it is my duty to read out loud the rules of this webinar. The first one is registered participants of CPD points have to appear live on webcam. However, for the ladies, it is their choice. If they want to cover their face, but they can cover their face, but they have to appear live on the webcam. During the lecture, microphone of all the participants except that of speaker shall remain in mute position. At the end of the lecture, there would be a 20 minutes question answer session. I have already spoken to the speaker about it. She is more comfortable if you ask questions during the session reserved for question and answers, which is 20 minutes, the duration of which is 20 minutes, but at the end of the lecture. During the course of the lecture, if you have questions, you can type it in the chat box, and any question which is absolutely necessary to be asked during the lecture, I will intervene and I will ask the speaker that question, and she will answer that question at that time. Participants on the Facebook, they can also type the questions in their chat box, which is being monitored by one of my colleagues. And that question, again, if it is absolutely necessary, that will be asked during the course of the lecture. Otherwise, that questions I will read out during the 20 minutes question and answer session. Now I will I'll move ahead for the introduction of the speaker. Ladies and gentlemen, it's my honor and it's my privilege today to present to you Tatiana Tronda. basically a civil engineer hailing from Belarus. She underwent 9 years of technical education starting in 2006 and ending in 2015 at Belarusian National Technical University, abbreviated as BNTU at Minsk. This university ranks at number 2 in Belarus, number 1 among the technical universities in Belarus, 293 in Europe, and 75 to 800 in the world, according to QS rankings. Technical education of Ms. Tronda, having enviable grades, comprised 3 distinct parts: an undergraduate program in industrial and civil engineering, a graduate program in construction, and a 3 years research program focused on bases, foundations, and underground structures. She has attended around 7 training programs on a variety of technical and language-related subjects. Having around 45 technical papers to her credit, her achievements have been recognized through at least 10 national and international grants, scholarships, and awards. Among other things, she is best known for her work on ground improvement of soils with dry columns. She is currently Senior Lecturer of the Department of Geotechnics and Structural Mechanics of Faculty of Civil Engineering at BNTU, delivering lectures, seminars, and laboratory works, supervising course and final undergraduate projects in soil mechanics and foundation engineering, and laboratory works in radiation safety. She is also currently working on a dissertation on ground improvement by dry concrete columns. Ms. Tronda has been highly active in coordinating scientific research work of students and conferences, seminars, and international academic exchanges, often being a member of the organizing committees. So this was a very short and a brief introduction of Ms. Tronda. And now I give the floor to Ms. Tronda. And please, ma'am, go ahead with your lecture. Thank you.
Good afternoon, everyone. So I'm just sharing my screen. Just a second. So do you see the presentation?
Yes.
Yes, and right now, yes, also. So good afternoon, everyone, one more time. Thank you, Mr. Tahir Sultan, for the introduction. It's my pleasure to be invited and deliver this lecture today here online. So let's get started. The topic is ground improvement in Belarus. Yeah. Before I begin, I'd like to notice that I come from a distant land and English is not my first language. Therefore, I may also not be using the same technical terms or notations that are used in English-speaking world. In Belarus, there are 2 official languages, Belarusian and Russian, and usually at work and in official documents we use Russian language. Therefore, fragments of drawings in this lecture may be in Russian because they are taken from actual design projects. So, therefore, I request the audience to kindly bear with me and extend to me the patience that I may be in need of. So my lecture, I would like to divide into several parts, and you can see them listed in the slide right now. So this is introduction, shortly geology of Belarus, some common geological conditions and complicated geological conditions, also the point of conventional foundations, which we usually or generally use here in Belarus with some examples and experience. Also, point of ground improvement, of course, a shortly overview and history, and several projects of experience of ground improvement in Belarus, and also conclusions and references, some references which I used for this presentation. Let's get started. Introduction. As we know that all loads from buildings and structures are ultimately transferred to the ground. Nowadays, there are many types of foundations used to transmit loads to the ground. Nevertheless, in some cases, ground improvement may be required. Therefore, this lecture shortly covers main aspects of geology of Belarus and presents the experience of conventional foundations and ground improvement in Belarus. Just to compare, I mean that I would like to share some conventional foundations which we use and its experience, and for the purpose to compare them with ground improvement methods and some experience of ground improvement here. So in general, 7 cases are considered in the lecture, and the main emphasis will be given to the ground improvement method using dry concrete columns, and we would discuss this part almost at the end. So, geology of Belarus. Now you can see in the map how far I am right now from Pakistan. So you can see Pakistan is here and Belarus is here. It's located in the west part of Europe. Belarus is somewhere between Poland and Russia, as you can see. Of course, its location influence on geology of Belarus. Shortly, most of the territory of Belarus is covered with quaternary deposits, and the thickness of quaternary deposits ranges from several meters to 300 meters. The deposits are composed of a complex of glacial, water glacial, lacustrine, alluvial, loess, Aeolian, and bog formations. And a feature of quaternary deposits here, it is a quite relatively high water level. The deposits of the glacial complex constitute about 88% of the total volume. And according to classification by Matveyev, the main genetic types of deposits of the glacial formation in Belarus include moraine, fluvial glacial, and lacustrine glacial. So for that, we can see the map of geomorphology of Belarus. So again, briefly, I can describe that in north of the country, there are many lacustrine and alluvial low loads. In the center, many of moraine and fluvial glacial lowlands and plains, and in the source there are many of lacustrine and alluvial lowlands. The next slide shows the information about quaternary deposits, and mostly in the north. Again, we have mostly we have clay soils. Then in the middle and in the capital of our country of Belarus, in Minsk, we have both sandy soils and clay soils, and in the source there are a lot of sandy soils and alluvial deposits. So it is briefly about our geology, and as I said, common geological conditions in Belarus include sand, clay sands, and sandy clays. We have also just clays, but it's quite rare, and in most cases they are in the north of Belarus. So we don't have rocks, and we don't have earthquakes here, but yes, we can feel some earthquakes, but they are far from our territory. But we don't usually calculate or design our foundations and structures for earthquakes influence or something like this. So further, I'd like to share some information about geological conditions, common geological conditions. I just took an information from one of the design projects, and you can see the geological cross-section of this construction site, from this construction site, and the soils which we have. Usually a lot of sandy soils, fine sands, medium sands, gravelly or coarse sands, as you can see, but also clay sand. In most cases, yes, we have clay sands. So the next slide can show you again the same information. Just before we, again, I just go back. We here can see the results of CPT tests, and the next slide shows the results of dynamic tests at this construction site. What about properties? Let I show you. So again, from this construction site, I put the information, and here you can see in the table normative and design soil properties and their values. Usually we show total unit weight, cohesion and friction angle, and also modulus of deformation for design engineers, for civil engineers, because usually we use these properties for design and calculations. So you can see that total unit weight vary from about 17 to 22. Cohesion, again, it depends, it is cohesive soil or not. So can vary, of course. Yes, sometimes up to 40 kilopascal. Friction angle, again, somewhere from 20 to 35, you can see, or 40, or for sandy soils for up to 45 sometimes, yes. And modulus of deformation can vary again from 10 to 30, 40 megapascal. So the next slide shows you the information about physical soil properties and some CPT results, again, for this construction site. And here you can see that clay sand, for example, have Artebeck limits like 25 and about 17%, yes. Saturation about 0.8, liquidity index about 0.3, and so on. Not all, of course, not all our soils have such high saturation, but almost all at the top. At the top of the ground, yes, they will be quite saturated. So the next slide shows you the same information, but for sandy soils, as you can see. For loamy sand and fine sands, water content is about 7, 5, 6, 4%, and some results of CPT tests also are here. And the end of this table, also, you can see some values for sandy soils. Okay, so it was common geological conditions for Belarus, but if we say about complicated, then we can describe them as follows, usually as follows. They include high moisture content, high water level, soft clay soils, loess soils, PET soils, soils with organic inclusions, and so on. And again, I'd like to share a fragment of geological cross-section from one of construction sites not far from Minsk, in the center of Belarus. So, and here you can see that we have soft sandy clay with the modulus of deformations only 4. Also sandy clay with units number 2 and 2A, yes, with modulus of deformation only about 11. Then clay sand number 4, about 8 modulus of deformation, and so on. And then at some depth, it is somewhere here, you can see unit number 11 here. Yes, this is peat and peaty soils, of course, with quite low modulus of deformation. So this is the construction site with quite complicated geological conditions. Yes, we could use here pile foundations and so on, but we used ground improvement at this construction site, and we will discuss it a bit later. So next chapter, I'd say conventional foundations. Yes, as we know, general purpose of foundations is to transmit structural loads to the ground, and we know such types as shallow foundations and deep foundations. Shallow foundations we can divide into spread, strip, mat foundations, and deep foundations we can divide into pile and caisson. Also, piles are divided into bored and driven piles, and we can use materials such as concrete, steel, and timber. This information is in general for conventional foundations, but what about Belarus? The next slide can show you the information that yes, we use all types of shallow foundations, and also we use pile foundations, not only driven and bored piles, but also vibro-stamped piles. And materials, we use usually concrete and sometimes steel. But I don't have any information about timber piles or something like this nowadays, so maybe we don't use them anymore. So let's go further. And here I'd like to share some information about experience of conventional foundations, which we use in complicated ground conditions. So it will be 4 cases, for solutions, and I'd like to give this information just to compare it later with the ground improvement methods which we use for another construction site. So yes, we can apply a pile foundation almost at each construction site, but it's not usually, but it can be not the most suitable solution or something like this. So the first one project is apartment house in Gomel. this is in source of Belarus, and here you can see such soils as sands, but also sands with peat and organic inclusions. They are located somewhere here, number 10. Here you can see unit number 10. So they are here. What about properties of these soils? You can see again in the table right now in the slide. And we should pay attention for number 6, 7, 8. Yes, the clay sands with the organic inclusions or with peat. So in most cases, we pay attention for modulus of deformation, because if it's quite low, then of course we cannot achieve requirements for settlements. So here you can see that values for modulus of deformation are quite low, about 5, 6, 8 megapascal. So it was decided to use at this construction site ordinary drive-in piles. Right now you can see them in the slide here. Yes, these piles were located on the barren walls. In the next slide, you can see pile and pile cap layout scheme. So it was precast compound drive-in piles used here, and the length of piles was 9 and 10 meters. And the next slide shows the information about pile formwork and reinforcement cage, just for your information. So again, this is the information from design projects, so some information can be in Russian here. Don't pay attention for this. If you need, I can translate something for you. The next project is an administered building in Gomel, again in the source of Belarus. Here again we have a lot of sandy soils, as you can see, fine sand, silty sand, also clay sand, and their properties are mentioned in the table. Here we should pay attention for silty sand unit number 3 and water saturated silty sand number 4. But in this at this construction site, we used also piles. As you can see, they are in orange here, because we have quite thick first layer, and this is made soil, and usually we don't use such kind of soils for as a barren base. I mean, as a base for foundation, because they're I would say this is the requirement of our regulations, and we don't have usually any properties for these soils, because it's something like denied. So we apply piles here, and in this project there was bored piles using technology of CFA. The length of piles was 6 and 7 meters, and here in the slide you can see again pile layout scheme, how these piles were located. And the next slide can show you detailed drawings of these piles, framework and reinforcement cages. Again. The next project, it is hotel and business center in Minsk, in the capital of Belarus, in the center of Belarus. And here you can see again as next soil units as sands and gravelly sands and clay sands, number 13, 14, 15, and 16. And again, we apply pile foundations here, as you can see in orange in the right of the slide. Just to, as you know, just to transfer all loads from the upper structures and building into more strands layers. So here we just wanted to pass through soils units number 5. It is a sand with the modulus of deformation only 7 megapascal. Also number 9, medium sand with modulus of deformation also 7. And number 13, it is clay sand with modulus of deformation only 6. So it was decided to just pass through these layers and transmit all loads into more strands layers like number 11, 15, or 16 with the higher modulus of deformation, as you can see in the table. So the next slide shows you the information about pile layout scheme. Again, under all building, you can see a lot of piles. And in this project, we use, again, CFA technology, board piles. And the length of these piles was 11 and 12 meters. So again, some information from the project. Don't pay so much attention for Chinese language because it was a customer from China, so it was double language project in Russian and Chinese. So this is information just from the design documents. And again, some information about reinforcement cage and about piles, how they were constructed and installed, in what way, shortly here. The next project is factory in Mewari. Again, we can see here a lot of soils, sand, gravelly sand, medium sand, fine sand, but also sandy clay number 4 and peat number 3. So in the table in the next slide, you can see their properties. It is normative and design properties, which we use for design of the foundations. Number 3, it's peat, and number 4, it is sandy clay with quite low, again, modulus of deformations, only 5.5. Just for remark, here we use not dot but comma to divide parts of numbers. I mean that in English speaking world we use dot if we divide, yes, 5.5. Just don't pay attention that we use here comma, not dot. Okay, let's continue. So this number 4, unit number 4, we would like also to pass through and to transfer loads onto lowest layers like number 9 and 8, as you can see in the slide here. So and this is number 9 and 8, clay sand with quite high properties. We can go back a little to see 8 and 9. and 8 and 9 here. Okay, and again, some short information about the technology which we use in this project. Here we used vibro-stamped piles performed under casing pipe, and detailed drawings you can see in this slide here. So the length of these piles were from 5 to 14 meters, and we used concrete class of C2025 here. Here, just for, I know that maybe it's not so clear, but it is just to show you the mass of these piles under this factory, and this is just a fragment of pile layout scheme. It's not full here, but just to show you how many piles there were in this construction site. There were piles under bearing columns and also under equipment. So here, caps and piles under bearing column, you can see in the narrow straight line, yes. And in the middle, there are places with piles under for equipment. So this is all with the examples, and let's go further. So satisfactory foundations, as we discussed, prevent in-ground failure of strengths and unacceptable settlements. And here in Belarus, we usually pay more attention for settlements. And this is obligatory for design and calculations of foundation here. So, but in some cases, ground improvement may be needed. For example, when one or both of above goals may not be met. And the next our chapter, it is ground improvement. Just shortly information from overview and history. So ground improvement is the procedure typically defined as using mechanical means to improve poor ground conditions. Ground improvement methods improve the engineering properties of the soil mass, which is treated to meet project performance requirements. Common reasons for ground improvement include improved bearing capacity, increased density, control settlements and permeability, mitigate liquefaction, and increase slope stability. So here in this lecture, we will discuss mostly the cases when we increase, when we try to control settlements, as I said before, because when we have a quite soft clay soils, yes, this is the problem for big settlements which can occur after construction. So this is the main, almost the main reason to use ground improvement in Belarus. But yes, also we use other methods, and there are other reasons for using ground improvement. So shortly from history of ground improvement, I'd like just to remind that ground improvement methods have been used since ancient times, and even, for example, about 6,000 years ago in China, ramped columns were used. Also, soil compaction methods using rammers have also been employed since Neolithic ages. Different types of rubbers were used about 1,000 years ago. about 2000 years. The Romans used lime for roadway construction and so on and so on. Many ground improvement methods were used in China in ancient times, about 50 or 1,000 years ago, and so on. What about modern ground improvement methods? They were developed since the 1920s. And for example, the use of vertical sand drains to accelerate consolidation of soft soils was first proposed in 1925, and then it was patented in 1926 in the United States. Also, cotton fabric was used in the United States, for example, in 1926. The fiber flotation methods was developed in Germany and used from 1937. Sorry. The first type of prefabricated vertical drains was developed in Sweden in 1947, and so on and so forth. So as you can see, that not so many years, just about 100 years for modern ground improvement methods. So they are still in development. And there are some novel and new methods in the world. So factors influence to the choice of the ground improvement methods are follows. So soils influence for choice, yes, their type and quantum and depth, their properties also, and the properties which we would like to or we desire to receive after improvement. Also availability of materials, skills, and equipment which we have, for example, to perform ground improvement at a certain construction site, and economics. The next slide shows you classification of ground improvement methods adopted by Technical Committee 17, ISMG. I took this information from the website, and I'd like to share and remark those methods which we use here in Belarus. Not all we use here. So in yellow, you can see methods which we use. In the category of ground improvement without admixtures in non-cohesive soils or fill materials, we use such method as surface compaction, of course, using a variety of compaction machines. And also in gray, you can see that I marked dynamic compaction using heavy weight, dropping a heavy weight. In gray, just because we have some regulation on this method, but I have no information that we use this technology nowadays. So more often we use surface compaction, of course. So the next category is ground improvement without admixtures in cohesive soils. Here you can see that in yellow, again, I marked methods which we use in Belarus. It is, these are replacement and displacement, and proloading using fill. Let's go further. The next category, ground improvement with admixtures or inclusions. Here we use such methods as fiber replacement or stone columns, sand compaction piles, rigid inclusions, and geosynthetics. And plus here, I would like to add that also we use not only sand or stone columns, but also dry concrete columns, and we will discuss them almost at the end of this lecture. The next category, ground improvement with grouting type admixtures. Here we use such method as particulate grouting and jet grouting. Yes, we use it. Not so often, but yes, we can use it. And the last category, earth reinforcement. We use here almost all methods, geosynthetics, ground anchors, and biological methods as well. So, what about regulations? Here in the slide, you can see regulations used for ground improvement design in Belarus. They are listed, not all, but many of them. There are 9 in the slide, but as I said, we have more. All of them are in Russian language. I just put here their titles in Russian as original title, and I translated them into English just for your information. So there are a lot of regulations, but not all of them covers all modern or new technologies, new methods for ground improvement, unfortunately. But you know, we here we update these documents quite often, and many of them will be not cancelled, but like closed for using, maybe this autumn or very soon, and we will replace them with another documents, another regulations, more updated. So go for them. And here again, I have some examples, examples and of experience using ground improvement. First 3 projects will be combined, as I remember, will be combined, ground improvement plus conventional and conventional foundations. Let's just look maybe more carefully for them, and then we will discuss using only ground improvement methods with dry concrete columns, as I said. So the first project is supermarket in Babruysk. This is again the not so big city in Belarus, and here also we can see many sandy soils. Yes, again fine sands, sandy clays, but also we have clay, silty clays with organic inclusions and peat, number 4 and number 5. Number 4 here, and it will be number 5 somewhere here. It is this cross section is just for 1 point of penetration test or CPT. So other points consisted also number 5, for example. So what about the properties of these all soils? Sorry. Also, we had peat number 9 here. What about properties of these soils? Here in the slide, you can see one of the point of CPT tests we had, and the graph, resulting graph for this point. So count resistance was from 2 up to 15, 20 megapascal for this point. And again, here we can see the table with normative and design properties for these soils. So again, we should pay attention for soils number, units number 2, 4, 5, 6, and 9. They are marked in red here. And again, we pay attention for modulus of deformation, which is quite low for unit number 2. This is sandy clay, only 6 megapascal, and plus I found the information that liquidity index for this soil was about 0.7. And next units, number 4, 5, and 6 also have not so high modulus of deformation, about 9 and 6. For number 5, it is 6. 5, it is sandy silty clay with peat. And number 9, it is peat. And modulus of deformation is only 2 megapascal for this unit. So again, it was decided to pass through all these weak soft soils and transfer the loads under them to most strength soils. We used piles for these purposes. As you can see in orange here, it is a pile, but also we use conical piles for ground improvement. And let's look at the map, at the scheme. And here you can see that again we used piles and under cap, under bearing columns at the perimeter of the building. You can see them. Plus, here this is a pull-out scheme with all piles. So plus we had the conical piles formed in the situ as rigid inclusions under the floor of the supermarket. Here in the middle of the building, you can see them. So under bearing columns, we used poured piles formed in situ on the caisson pipe, and the length of them were 13 to 14.5 meters. And under the floor, we used rigid inclusions, and you can see the drawing of this inclusion performed as conical piles formed in situ with length of 3 meters and diameter from 0.325 up to 0.63 meters. It is from the bottom to the top of this conical pile. This kind of piles, I mean conical piles for ground improvement, allows to compact ground at upper layers here between the columns, these conical columns. They are quite common for ground compaction at the top, and we can use them for ground improvement of top layers. It is quite common now and not a new, not novel technology. It's quite old technology, and it has approved results, I'd say. So we use them to compact upper layers, and of course it helps us to improve properties of upper layers, and then to transmit the loads from, as in this project, from the floor of the supermarket to the upper layers, and with no using any piles on the floor, not applying big mat or pile raft foundation, just ordinary piles with caps and ground improvement under the floor. The next project is an apartment house in Minsk. So again, let's look at geological conditions. We have, again, many layers, many sandy soils, fine sands, medium sands, gravelly and coarse sands here. Then let's look at their properties of these soils. Again, here in the table, we can see normative and design properties values. Number 4, this is medium sand with not so high modulus of deformation, again, just 13 megapascal. And number 8, this is gravel and coarse sand, but it is low strength sand with only 7.7 megapascal modulus of deformation. More information about properties of these 2 units. Number 4, again, you can see that water content over an average value is 3.5, density 1.51, void ratio 0.82, quite high void ratio. So it was again discussed to pass through this layer with piles. And for unit number 8, we can see also some physical parameters as water content, about 3.5%, density 1.53, and the void ratio again about 0.8. Here, this is the column with the result of dynamic test, the last column. And in the next table, you can see the results of static load test. We call it STAMP. And here you can see the result. Again, we would like to receive the modulus of deformation. And this is the column in megapascal here for these 2 layers, number 4 and number 8. So here you can see modulus of deformation about 14 and 12 for number 4, and about 7 and 3, 8 and 2 for number 8. These different values are from different, I received from different depths. So here you can see in meters the depth at which we receive these values. Let's go further. So here we have loads to foundation scheme. You can see the shape of the building, the shape of this apartment house. And so according to the geological conditions, of course, it was decided to use pile foundation. So it was used piled raft foundation in the main part of this building. I will show you in a second here where. And in the other part, we used shallow foundations on improved ground. In that part, in those parts where loads were not so high. Let's go back, and I will show you here in this part main part of the building, we used pile raft foundation, and in this part, in the right corner, upper corner, we used shallow foundations here with the ground improvement under them. Let's go further, and I will show you here in the scheme. You can see raft and the foundations layout scheme. So this is the slab, foundation slab under the main part of the building, and this is the part with the shallow foundations here in the center. Yep, with the ground improvement. So which kind of ground improvement we use here? This is this part here in the right upper corner. Here you can see. So we used ground improvement, two types in this project. Just compacted sand ground under some of the foundations, and on the others we used inclusions, concrete piles formed in situ. We used concrete class C810. Diameter of these piles was 0.42 meters, and the length was only 6 meters. So here you can see these foundations. I mean, shallow foundations, upper foundation. Our drawings are made for foundations on compacted sandy ground, and the lower drawing is for shallow foundation on inclusions, ground inclusions. So these rigid inclusions were applied, as we can see, on only on the shallow foundations, just to improve weak soils on the two-story part of the house, and those places where loads are lowest. So, and here you can see again a more detailed drawing for board piles and the main part of the building, and the inclusions for which we used for ground improvement. Of course, they were without any reinforcement cage, as you can see here. It was just concrete piles formed in situ, made of concrete class C810, almost the lowest class, and without reinforcement cage, just because we wanted to use these inclusions to improve soil properties, to improve the base, and this can allow to transfer loads to upper layers of the soil. So not to transfer them to the lowest, most strength soils and layers, if we have not so high loads in this part of building. And the last, and maybe one of the most interesting design projects and examples, it is a multifunctional complex in Minsk, in the capital of Belarus. Here you can see how it looks like. There are 3 buildings, 1, 2, and 3 in the middle of this circle. The third building is located. So, and we used ground improvement methods under this circular building, and also in some part of this third building, it is a shopping mall, and but we will discuss this part, this big circular building, and application of ground improvement, actually dry concrete columns under this building. So shortly, there are some apartments at upper stories and some shops at the level of ground in this building. So what about geological conditions of this construction site? You can see in the slide right now, again, just a fragment of cross-section at this construction site were made. And here we can see such soils as the first number one here. It is made soil. We usually just cut it and don't put any loads to these soils. Next, number 2 and 3 units, 2 and 3 here. 2, 3, number 3 is here. It is soft sandy clay and medium strength clay, sandy clay, with the design properties you can see in the table. So again, Modulus of Deformation is not so high, just only 3.5 for soft sandy clay. It is unit number 2, and about 8 for unit number 3. They are located almost at the top of the ground. Then we have strength sandy clay. This is number 3A, and again number 4 and 5. These units are not so strong. These are sandy clay with organic inclusions, and the Modulus of Deformation is only 9 megapascal. And number 5, it is mark, chalk, and peat, with the Modulus of Deformation about 12 megapascal. So here, number 4 and number 5 are marked in pink and red. You can see number 4 here in pink, and number 5 here. This is mark, chalk, peat, and so on. So, and only under all these layers, we have number 10, number 13. These are medium strength coarse sand and strength medium sand with quite high Modulus of Deformation, as you can see in the table right now, more than 20 already. So, and these layers were located almost at the depth of 30, 35 meters. So quite low. So according to these geological conditions, it was decided to discuss several solutions for this construction site. And we compared pile foundations as quite common used here, and ground improvement. So the first solution was to apply pile foundations, and you can see again a fragment of this project in the right here. Of course, we should pass through all these weak, soft soils, as we just mentioned, number 4 and number 5. They are here. Number 4, 5 here, and to transfer all loads to the most strong layers, number 10 and number 13. So in this case, piles should be about 30 or 32, 35 meters long, quite long piles. But we suggested, it was my colleagues, professors for my department, from my university, and we suggested to use the ground improvement method. Quite new, but it was suggested to use dry concrete columns. Here in the middle, you can see how they are located in this cross section, geological cross section. So in purple, these are dry concrete column. Just for upper layers, we propose to use them. Then at the top of these columns was proposed to use sand cushion, sand transfer layer, and and also it was proposed to use reinforcement of this transfer layer, sandy cushion. And then only, sorry, where's my mouse? Here. And only then we should locate foundation slab, or mat, as we call it. Here you can see in gray with red here. So we compared these two variants, these two solutions, and you know, it was more cheaper. It was more cost effective to use ground improvement, the second solution, for this construction site, because it allows to save about 75% of the cost of foundations. So it was decided to use this technology here. Not pile foundations, not pile raft foundations. And the next slide, you can see how these dry concrete columns can look like in their cross section. So this is just column filled with dry concrete. And in this project, the length of these dry columns was about from 3 to 12 meters. Their diameter was about 0.3 to 5 meters, and we use concrete class C8-10, almost the lowest. Why? Because it allows to save to be okay. I will describe a little bit later. It helps to save money for this technology, of course, but it works even with such low concrete class. So dry concrete columns were made according to vibro-stamped piles and casing pipe. That's why the diameter is not so how to say, not so beautiful. I mean, that's it's only 0.3 to 5 meters, not 0.4 or 0.5 meters, because we have steel pipes and for this purpose, and they are standard form. So the diameter is like this. So in the right corner, you can see the fragment of reinforcement of sand cushion, which we apply here at the top of dry concrete columns. So also we used 3 layers of reinforcement for this sand cushion here. Let's go for them, and I will show you just a fragment of dry concrete columns layout scheme. As you remember, the building has a circular shape. Here you can see again like this, And this scheme just covers 4 sections, just 4 lowest sections here, 4 lowest sections you can see. And this is a mesh how all dry columns were located and how many of them were applied here under all the building. So, and now more detailed about dry concrete columns and some researches which me and my supervisor made, because this is the topic of my dissertation, and so I'd like to share some information that we received. So, dry concrete columns, as we discussed, they are made of dry concrete mixture. So, dry concrete, we use dry concrete ingredients without water, just ordinary class, almost all lowest class of concrete, C810 for this purpose. So we use dry concrete ingredients and insert them into the ground using casing pipe. After that, we pull out this casing pipe, and our dry concrete mixture allows to absorb surrounding water. So maybe I haven't mentioned before that upper layers were water saturated, but they are quite soft, number 2 and 4, as we see clay sand, soft clay sands, they are saturated, and this technology allows to absorb water from these surrounding soils. So dry concrete ingredients of concrete absorb surrounding water, and at the end we have hardened columns. Hardened columns. So this is the first point. We decrease water content of surrounding soils, and it allows to improve their properties, to decrease them. I mean, especially modulus of deformations will decrease, and so on. But also, we use technology vibro stamping piles here with the casing pipe with the close end. So, and when we use this technology, it allows to compact surrounding soils. So, using technology and dry concrete, these 2 points allows us to improve soil properties, compact them, and drainage them. Here you can see also the mesh, how we can arrange these columns. Also, it can be used triangular or another mesh. Here we used squared with the distance between columns equal to 3 diameters of this column. So it was about 1 meter. Some pictures from some photos from construction site made from construction sites. We used, as I said, casing pipe press. Here you can see that the casing pipe is inserted into the ground. Here it's this pipe is empty. So we press this pipe into the ground. With pipe is closed at the end, but this end is losing. Then we fill this pipe with dry concrete. Here in the next photo you can see it. And after that we pull out casing pipe. Loosenant remains at the project level, and pipe is pulled out, so we formed dry concrete columns. And here in the next slide you can see heads of these columns from different points of the construction site. So here and here you can see them, how it looks like. Then, as I said, about these columns, we used sand cushion with the reinforcement. So here in the slide, there are some photos from construction site where this cushion, this sand layer was made. So filling up and compaction of the sand cushion at two first pictures here. Compaction you can see, and how it looks like reinforcement, horizontal reinforcement of the sand cushion you can see in the third photo here. These are steel in plastic pipes filled with mortar. It's not just steel in the soil, in the sand. No, steel is in plastic, placed in plastic pipes. So, about some in situ tests I'd like to tell. Here in the slide you can see the results of CPT tests before and after application of dry concrete columns. So blue line, this is for before application of columns, and red line, this is for results after application of dry concrete columns. So you can see that almost, you can see almost each point we have increase of modulus of conus resistance. So almost everywhere the red line has higher values than blue line. And these tests were performed in order to prove the possibility of using such technology, that this technology works and we can use at this construction site just to prove it. Okay, so also we had several static load tests at this construction site. Here you can see some of them, some of the results. So first point and second point here, and in the table you can see again models of deformations that which we received. It was 56 megapascal and 52 megapascal after application of dry concrete columns, of course, because before, as we already seen, we had modulus of deformation about 8 for this layer. For clay sand layer, we had only 8 megapascal. So results were quite impressive. And after this test, we decided, yes, we can apply this technology at this construction site, and it works. Then also we had a series of laboratory tests. Here I'd like to share 3 of them. So first test was performed to show again to show applicability, to show that we can use this technology instead of piles, and we use laboratory for this purpose. It were made several fragments. You can see in the slide here with different lengths of dry concrete columns. It was 20, 15, and 10 centimeters long, and also the same shape, the same length, and the same soil was used for test with ordinary piles. And we would like to compare them. So here in the slide, you can see the results. For these tests. So here, the red line, the first red line is just for slab. Only stamp was applied. So we just a second. Here we have just slab without piles, and we tested this slab only, and the result you can see here in red, in this red line. Then 3 results for piles foundations. Blue, green, and yellow lines for 10, 15, and 20 centimeters long piles. They are here. And then we received 3 lines for dry concrete columns. So again, 10 centimeters long columns in blue, 15 centimeters columns in green, and 20 centimeters columns in yellow accordingly. So as you can see, we received, Okay, so as you can see, we received quite good approval that dry concrete columns works in soft clay soils. Yes, these results were received in laboratory, but they were also quite impressive. So just to show quality of picture, you can see these results that this technology works. To compare these results, we draw some graphs. So here you can see blue line for only for piles, and green line for dry concrete columns line. This line is for dry concrete columns. So what it shows, it is that this is like a coefficient of reinforcement, that when we use only piles here in blue line, you can see that we have just like reinforcement influence. But if we use dry concrete columns and the result in green, again, yes, we have not only reinforcement, but also drainage of saturated clay soils. And this fact allows to increase reinforcement of our and improvement of our clay soils. So the next graph shows you the increase of modulus of deformation. So again, the blue line is for pile foundation, and the green line is for dry concrete columns. Again, we can see that dry concrete columns have much more big influence than ordinary pile foundation in these conditions. So again, thanks to absorption water from surrounding soils, we can achieve such result using technology, vibrostamped piles, and dry concrete mixture. We can achieve such results, but it was laboratory tests, and the results are given here from laboratory tests, just to remark. So the next test we had in laboratory, it was made to prove change of the water content in clay sand, and to achieve some results on density of dry concrete columns. We were tested them on press. Here you can see in this in the photo. So properties of soft clay sand, which we used here for this test, you can see in the slide. They are mentioned here. What we received at the end of this test, you can see in the table. So we would like to receive water content changes, and this experiment lasted 56 days. So the results you can see in the table. Yes, here. So water content was the first day was only was 13.7% and then at the end of this experiment it was 12.5%, and it allowed it to decrease liquidity index from 0.7 to 0.5. At the end of this experiment, we, as I said, tested our sample of dry concrete column here and received the force of 20 kilonewton, at which it was broken. Sorry. So in this experiment, ratio water to cement was 0.8. At the end of the experiment, we calculated this ratio. Sorry. So here also I'd like to add some information about the second sample we also tested. So the first we discussed, results are here, and the second one was made of concrete with more cement. You can see a ratio here for sample number 1 and sample number 2. This is concrete, sand, and gravel. So we used more cement for the sample number 2, and as a result, we received force 25 kilonewton for this sample number 2. So I would say that of course cement influence for results, but it wasn't the main objective to increase the strength of dry concrete columns, of these columns, because the main purpose is to increase, to improve soils at upper layers. So these values are more higher than it would be for soils. So like a main principle of reinforcement is to include some inclusions which are more have more strength than soils we try to improve. And here you can see also results of the third laboratory test. Here we would like to investigate how much can be liquidity index changed during the process of dry concrete columns application of them, because these values, I mean liquidity index, we use in our design projects usually when we meet clay soils at the construction sites. Almost all our documents reference to, or tables are reference to liquidity index. So here we try to test several boxes with clay sand again, but with different water content and different liquidity index. Here you can see before values we have like 0.33, 0.4 up to 0.8, and then after 28 days, we tested these samples also and soils. So we received water content changes, of course, and again calculated how our liquidity index changed. And in the third line, you can see how it changed for each box. And the last line, shows you the information about delta, the difference between both values. So how much it changed, how much liquidity index changed for each box. So as a result, in general, we can say that liquidity index can change about 0.2 for roll boxes. Also, one of the purposes of this test was to prove that even not so high water content of the soil can be enough to receive hardened soil, hardened column. So as you can see, they all 6 samples here in the slide, they were hardened. So this is all. Let's go to conclusions. There are many types of foundations which we use, of course, in Belarus, and their choice depends on geological conditions of a construction site, as we discussed, availability of materials and equipment, and also economics. So generally, construction sites are presented with sands, clay sands, and sandy clays in Belarus. In these cases, conventional foundations are used, and as we discussed, usually it was pile foundations. In complicated geological conditions, such as soft or peaty soils in the ground, sometimes ground improvement methods are used. Here in Belarus, one of the most promising and cost-effective ground improvement methods is application of dry concrete columns, which allows upper soft clay soils to be compacted and drained at the same time, and as the result, strength and deformation properties of natural soils improve, and the cost of foundations may be reduced by 75%. As we discussed for the project in Minsk, I mean the multifunctional complex in Minsk. So some references which I used for this presentation, you can see right now in the slide. Some websites from ISMG, and our Belarusian regulations, where we can find. Thank you so much for your attention, and right now we have time for questions, so please, I would be glad to answer your questions if you have. Thank you very much.
Thank you very much, Ms. Tronda. That was a wonderful lecture. Now we are really very pressed for the time. So Mr. Suhail Kibia has asked 10 questions. So kindly answer them very briefly. We are really tightly pressed for the time. You know, then the problem is we cannot manage the recording of the video more than 2 hours and 15 minutes. So we have, I think, hardly 15 to 20 minutes left. Anyhow, we try to finish it as soon as possible.
Okay.
The first question is, does your design require the board piles tip to be placed in firmly soil essentially? Did you get my question? Should I say it again?
Yes, please. Could you repeat it?
Does your pile design require the board tip, that is the tip of the pile, to be placed on the firm soil? I mean, the pile tip, is it to be placed on?
Sincerely, I understand. Yes, it is required, not obligatory, but in most cases, the tip, you mean the end of the pile, yes, should be replaced to strength layers with quite high properties. I mean, usually, for example, we place them to soils with modulus of deformation about 10 or 15 or higher. I mean that usually we place them, yes, in strength soils just to transfer the loads into these strength layers. If I understood your question.
Yeah.
Yes.
Normally, we go for with the values of the standard penetration test N. So normally, if it is above, in Pakistan, if it is above 8 or 9, I mean, that is more or less acceptable for a firm soil. Anyhow, so the second question is, in the pile design, do you account for negative skin friction in the soft soils?
Yes, absolutely. Yes, we account it, and yes, we have this point in our regulations, of course. Yes, especially for soft soils and peat soils. Yeah.
Okay. Now the third question is, any base grouting practice in use in Belarus? Base grouting.
Base grouting. Perhaps I have no information about this, but I don't know. Unfortunately, I don't know.
Okay, okay. The fourth one is, are the soil deposits normally consolidated or under consolidated in Belarus?
Normally, I think that both. I don't know. Normally, I think both. Yes.
Both. Okay.
Yeah.
Okay. And while you were discussing the short concrete piles, the question was, what is the normally allowable load capacity of short concrete piles?
Excuse me, could you repeat one more time?
It is allowable load capacity of short concrete piles.
Sorry, I think that I can't catch the question.
You know,
maybe.
Mr. Kibria is asking that, you know, the short concrete piles which you were referring in your lecture, what is the load carrying capacity of that pile?
Load capacity. If this were piles not for ground improvement, then usually these piles can stand something like 300 kilonewtons or something like this, or more or less. It depends, of course. But for ground improvement inclusions, we don't calculate these. Of course, we don't calculate these values because it's not the purpose them to stand these loads.
Okay. Now his sixth question is when you were discussing the ground improvement, at that time he asked the question. It was, I think it is not a question, it is just a note, which or a comment. He has written some energy method to bake the ground to result in the ceramic-like effect for ground improvement. You understand the ceramic-like effect?
No, I think no. Suppose that ceramic.
Tatiana, can you unshare the screen? I will show you the questions. Maybe. Thank you very much. Now I will share the questions, and you can read the questions yourself. Okay.
Okay. Yes. Sure.
Just give me a second. I'll just. Huh? Now, can you share? Can you see my share screen?
Yes. Yes.
Now, see the question number is the sixth question, number 6. Some energy methods to bake the ground to result into ceramic-like effect for ground improvement.
I suppose that we have some information on regularities, but I don't think that we use something like this method to bake the ground. Maybe I have not so much experience in this, so I don't know.
Okay, we leave it there. So number 7 is, has modulus of deformation been evaluated using CPT-based correlations?
Sometimes modulus of deformation is evaluated using CPT, but sometimes from static load tests, and sometimes from laboratory compressed what's it called, odometer tests or something like this. It depends. For example, in most cases, yes, perhaps using CPT, but not for all soils. For example, if we receive lowest values from laboratory tests or from static load tests, then we will take these values for our calculations, just for safety.
Okay.
I mean,
Okay, now the 8th one is, question number 8 is, use of permanent steel casing will tremendously lower the load carrying capacity. Why is it preferred?
Yes.
That is when you are using the casing for the pile, and obviously the permanent casing you don't pull out. So that will,
Yes, please.
So he's talking that the contact between the soil and the concrete will not be there, it will be with the casing. So that will reduce the load carrying capacity. So why it is preferred, he's asking.
I mean that we don't use permanent steel casing pipe usually. It's just for technology to install piles in the ground. We don't remain these casing pipes, steel casing.
So you pull it out. Basically,
yes.
Yeah, it is a temporary casing. Once the concrete is poured, then you pull it out. That is okay.
Yes.
That is okay. Thank you. And the 9th question is, the pile raft foundation, typically what load percentage is carried by the raft?
It's a quite interesting question, because my supervisor have research on this topic, and as I know, he noticed that about 30% is carried by raft and others by piles. Yeah. Sorry, Tahir Sultan, I cannot hear you.
Yeah.
Yeah.
Question number 10 is the main reasons for using dry concrete in place of wet concrete. This question he asked when you were discussing the dry concrete columns, you know. So this is, why do you use the dry concrete? Why don't you use wet concrete?
The main reason why we use them, because we would like to receive two results. I mean, first, it is a drainage of saturated upper soil layers, such as clay, sands, and so on, and also to compact them. Why we don't use wet concrete? Because it was enough water from surrounding soils to harden concrete, dry concrete in dry concrete columns. So and also it was, you know, like one of experiments. Will it work or not? So yes, we can have this solution also, but it was decided to use something novel, and we applied dry concrete columns there. Maybe I should mention that it wasn't the only one construction site where we used this technology, but at some similar construction sites, we also use dry concrete columns. So it is quite a promising method. But for some special conditions, geological conditions, not every one construction site, of course, will suit, but in general, those construction sites have quite low strength soils, at the top and the middle and the depth and so on. And we would like just to improve upper layers to have a possibility to transfer loads onto these upper layers.
Yeah, our very senior participant, Mr. Suhail Raza, he is asking the question, by dry concrete, do you mean a mixture of crushed stone, aggregate, and sand only, or without cement? He is asking that the dry mixture is without cement or it is with cement. I think it was with cement. What, Tatiana?
Yes, we use ordinary mixture, cement, gravel, sand for dry concrete.
That is okay, but it is a very lean mix, I think. So mixture ratio, we are not interested. That is, you only wanted to know whether we use cement or not. So that is okay. And,
yeah, sure.
Yeah, and then we have Mr. Nabil Ahmed. He's asking the question, what is spacing criteria for the dry concrete columns? Spacing criteria, that is between the two piles, what is the spacing criteria?
Yes, usually we use such criteria like 3 diameters between columns or between piles. It was just taken from piles criteria, I would say. So yes, about 3 diameters between columns.
Okay. Now, ma'am, we have one question. It is the last one now. It has come on the Facebook, and it is Mr. Gondal who has asked this question. What is this question? How you select base of the column based on SPT, standard penetration tests. Standard penetration test is the N value, you know, N is equal to 8 or 10 something. Do you have any mind, any value of N based on which you select the size of the column? This is what he's asking.
Perhaps I didn't understand the catch.
Okay, leave it then. I think we should, that is, just a second. I can read that question again, but how do you select base of the column based on SPT? You see, as I told you earlier, here we have a common practice of using N values, which comes from the standard penetration test. That is, which is a very popular test here based on American standard of testing material, ASTM. So here normally the convention is normally if there is no complex problems in the soil, normally when the value of N is below 6 or 5, we straight away go for the pile foundation, solution of pile foundations. We don't go for the conventional foundations. Anyhow, I'm really sorry, all the participants. We are now extremely tight with the time, so I have to give a little time to my co-host Rizwan Mirza if he wants to say something. And in the last, I would like Sohail Kibriya to give a thank you note to our honorable guest speaker. So Rizwan, my co-host, would you like to say something, please?
No, I accept to thank our speaker. It's been a very informative and very useful lecture. And I think it's an area where we have all learned. Thank you very much.
Okay, thank you, Rizwan. And Sohail Kibriya, please be brief. I have really tight with the time now. Thank you. Please go ahead.
Thank you. Hello, Ms. Tatiana Tronda. Sohail Kibriya here. I would like to share with all the participants over here that I discovered this excellent speaker of today first in Seoul back in year 2017 during the 19th International Conference on Soil Mechanics and Geotechnical Engineering, and then now this year in 2022 in Sydney. So I had requested her to deliver a lecture of her experiences in Belarus, and I would thank her immensely to take pains for accepting my request on behalf of Pakistan Society of Civil Engineers to deliver an excellent lecture indicating the technology being used. They are very useful for us. And I also appreciate, Tatiana, your patience for listening to my long list of questions. I really am very happy to learn that dry concrete, of course, use of dry concrete will be very useful in wet grounds, soft and wet areas where you have demonstrated with the laboratory testing that the liquidity index that drops significantly.
Sohail, I have to stop you there, please. The computer issue, the whole recording will be cancelled. If I please.
Thanks a lot. Yeah, thank you very much, and we'll inshallah we'll invite you again probably at some appropriate time, subject to your availability. Bye bye.
Thank you very much. Sorry, Mr. Tahir Sultan, we don't hear you.
Yes, thank you very much, Tatiana. Again, I hope I pronounced your name correctly, and
Yes.
like the way Belarusians do. And if I don't, I apologize. Anyhow, the lecture was, as my co-host and Sohail Kibriya said, the lecture was very informative, a very good lecture for the young engineers, and I hope the experienced engineers must have got also adequate information from adequate knowledge from your lecture. So now we come to the end of the lecture. For the announcement for the next lecture it is taking place on 10th September 2022. The topic is good practices in structural engineering, and our speaker is Javed Bashir Malik. As you know, Mr. Malik, he is based in Houston, USA, so there will be a huge time gap. We are unable to announce the time today for the lecture. It will be sometime in the late afternoon or at the start of the evening. That time we will coordinate with him and we will announce when the advertisement is posted on the internet. So, but it is on 10th September 2022. Topic is good practices in structural engineering, and Javed Bashir Malik is the guest speaker. Tatiana, it is our practice. We will present you a shield for the nice informative lecture you have given. My colleague Sadia will send you the shield and your certificate for delivering the lecture by courier mail on the address which you have given. And for the participants, you people can collect your certificates 17th August, which is Wednesday. It is Wednesday from our office, 148D Faisal Town, extension Lahore. And the telephone number is 0347 462 5111. And the contact person is Ahmed Ikram. I repeat it. Collection of certificates from 17th August 2022 from 148D, D for daughter, Faisal Town, extension Lahore. And the telephone is 0347 462 5111, and the contact person is Ahmed Akram. So thank you very much, all of you. Tatiana, best wishes, and God bless you all. Thank you very much. Allah Hafiz.
Thank you very much for this opportunity. Thank you.